What to do? Just all particularly will sign up. You just sign up. Come. Kavita, it is good. Richa, where are you? Come. So, that's like me. That's just so many lines. Well, I can cover the points. Just stupid. Karthik, you just say, yes, I know. What's up? Not taking it on my camera means photo not happening. That's it. Straight away. Okay. Fine. Tell it now that it's very spelled. Thank you. Cheats. We got the top comments. Good evening, everybody. Yes, look at this. Ready? Wait. Yes, look at. Thank you. So again, welcome. We start off this with a set of a briefing of 15 minutes on 5 topics. So I request the coordinator, Professor Parthapratim Das, along with the other 4 speakers, namely Professor Mayank Vats, Professor Richa Singh, Professor Amlan Chakraborty, and Professor Tanmay Chakraborty to come on stage, please. And I hand it over to Professor P.P. Das.
Okay, welcome everybody. So this is just a very lightning brief. So I start with the imperative for cross-sectoral AI measurement. So the whole idea is AI is besides whatever it is doing, it is collapsing the boundaries between different sectors. So it will future AI systems will or it's already will need to transcend governance, healthcare, retail, everything. So in terms of measuring the performance of these AI systems, their robustness, fairness, usability has to happen across sectors, not in silos. So while we have been working in a team to focus on multiple specific domains like healthcare, governance, and manufacturing, and so on, it is imperative that we design adaptable frameworks for evolving AI and complex human AI interaction. So that's been our primary cross-sectoral focus in the whole structure. In terms of some specific research agenda, here are some of the core components we have been looking at: sectoral world models, cross-sectoral metric description language, otherwise it will not. So it's basically the interoperation issues that come in, inter and intra-sectoral metric flow, recommendation of metrics, and so on. We hope that adaptable framework for AI evaluation will will happen as an outcome, foundational metrology and governance for AI. So cross-sectoral being the key area, integrated testing with domain-specific translation. So it's just not cross-sectoral; it should be translatable to specific different domains where we are hoping to do pilot with governance, healthcare, manufacturing, logistics, and so on. So that's the first perspective. I would request Professor Richa Singh. You can present from there also if you want. Okay.
Thank Good evening, everyone. Thank you, Professor PPT, for this. So like Professor mentioned, the second vertical is healthcare. Uh, so we have 5 thrust areas. The very first one is related to open platforms and benchmarking. Now, if you're building healthcare solutions for any country, we can't have public general scale healthcare models that work for every country, right? Because the demographics, the characteristics, composition, body composition, all of that is very, very different. If you look at the average height of an Indian male and Indian women versus average height of a Caucasian person. It's very different, right? So any kind of metrics that we are doing, any kind of measurements, any kind of solutions that we are developing have to be more tailored, right? So that is what we're targeting in this project, and it started with collaboration between India and Germany, but it scales up to any country that we are looking at and has to be adapted to different countries. So that is why our first thrust area is open benchmarking and creating open platforms where we can collect this data, annotate this data with respect to the practices, the medical practices, the clinician practices that are being followed in that specific country. Point of care explainability. So, in any healthcare solution, explainability, AI based healthcare solution, explainability is very, very important, right? Whenever we go to a doctor, we are always asking why this, why that, what is this, what is that, right? So, if same goes for a doctor also, that if we are suggesting, if any AI solution is suggesting a doctor that this is TB, this is something else. And I remember in one of the sessions earlier this morning where I was, the speaker said that he had presented a CT to one of the doctors, and they said, "Don't do lumbar puncture. Thank you. Don't do lumbar puncture." I mean, the reason is why. Why should I not do the diagnosis that they got was correct, but then obviously what is the reason of not doing it, right? So what is explainability? Then personalized digital health and wellness, preventive healthcare in setting like ours, preventive healthcare, or for that matter anywhere, preventive healthcare is very, very important, right? Why wait for something to happen before you start taking any precautions? And then public health AI, given that the ratio of a doctor to patients, one doctor treating how many people is significantly, we need to work on it, right? So can we do public health AI to reach to the masses? And these are the key challenges that we are looking at. Explainability, the fragmented standards across countries. So how do we unify that? There's significant data diversity gap, and we need to come up with model metrics. Just specificity and sensitivity is not going to cut it. So we need to come up with metrics which are targeted towards the application that we are looking at, right? And in all of this, trust becomes very, very important, because in healthcare, trust and explainability and accuracy, these are the three things that matter a lot. So with that, thank you.
Thank you very much, Professor Richa Singh. I would next invite Professor Amloj Chakraborty to talk. We can go into 15 minutes.
Yeah. So what I will be telling, I will be speaking on the metrics for manufacturing. And what we look forward is that we are transforming from the industry 4.0 to 5.0, which means that automotive AI to human-centric AI, right? And trust and resilience are some of the issues we wish to take care here. And when we look that there are certain critical areas like the AI models are black box, and we have the biases and reliability gaps in terms of the failures of the instruments and the sensors which drives our machines, right? Those are point of concerns, and obviously the security risk in terms of the data security, privacy, and the attacks, the poison attacks. Okay, and obviously we have seen some of the examples, like we have seen that the cost of OPEX, the opacity, okay, for AI leads us to the biasness, right? Biasness in the scoring, and we have seen some examples of some of the countries' AI systems, right? And also we see that the system's failure is not that statistical estimation of failure is not always the operational failure estimation in the right direction. So those are some of the things we need to take care of, right? And so the direction should be that we should have an auditable standard, and the mechanism is to be set, okay, for to maintain the standards and compliance for the AI. And we need to look into some of the actionable things, that why models have failed, right? Uh, Okay, the puncture in the data. What caused the puncture in the data? What caused the failure, security failure, right? And we need to compare the AI systems across the various platforms to make a static benchmark. Okay, and uh, so target is that we need to look forward to the safe and scalable operations of the AI. And if we want to go in that direction, what we need to look, we can look on to the following four key matrices which we have seen and studied and done research, a bit of research. Okay, so the first one comes the transparency and explainability, which tells that means, okay, what is the why the model has gave that particular result, and what are the core issues of the model, whether the explainability of the model supported by the model creation itself, or it is just okay, just a sort of a statistical prediction, okay, right? And we need to have the demographics equality, and we need to have the equity also. So when the model is losing, whether the model is losing for a particular group or a demographic group, or it is creating good only for a particular, okay, particular sector, right? That means, and if the model is doing good or doing bad, it should be, okay, it should be across the, okay, distribution. It shouldn't be in a skewed manner. Yeah, the key metrics are obviously, that means we need to have the robustness, and we need to have the drifts will be there in the manufacturing system. A lot of sensors are there, instruments are there, data drifts are there, policy drifts are there. So can we adapt to those drifts? Right, and obviously okay, if the direction towards accountability is that we need to have the audits which should be on the compliance. Okay, we need to look into that, means how many times the human has overridden. Okay, because if human override, the trust on the AI decreases, right? And we need to look forward to that, right? And whether we have a complete traceability starting from the data to the maintenance of the AI models, right? And if we look into the future roadmaps, we need to have the standardizations. There are standardizations in international level have done, okay, right? We need to follow those. We need to have this uh, okay, the adoption by the SMEs. There are a lot of challenges because we have a lot of AI requires the competence, and the competence, okay, those competencies might not be there in the SMEs. Okay, so how they will adapt to those? We need to have the models which can be just go models, okay, which are explainable go models, and that may be the strategy. And obviously the real-time operations, we will not go with the, we have the edge computing where we can look into the monitoring of the systems all throughout the lifespan. Okay, so those are the things we can look forward. And obviously unified governance, okay, starting from the capture of the data to the maintenance, and at the at different levels of the system, we need to have a one flow of governance and be defined by the policy and compliance. And I think that's all from my side here. Thank you all.
So next, Professor Mayank Vatsa. So Mayank, there's a clock that you can see here. Please stack up the 3 minutes.
Sure. Thank you, Professor VPD. So, I'm Mayank Watts, and I'm going to actually talk a little bit differently. Think of this way: governments are going to use artificial intelligence in their decision making, right? Day in, day out. Probably they're already using it, right? But if you ask a government official today, explain the decisions. The government officials, if even if they're using the artificial intelligence, they are going to explain the way they have understood the decision, right? So the whole objective is that if governments have to use artificial intelligence and they have to use it, then how to ensure that the governments understand, or the governance is understood well by the AI tools, so that can be explainable to population at large. And more importantly, like, can we actually audit the decision making process, and the whole uh, circle of governance, can this be made auditable? And that's where, like, the whole beauty of taking the AI to 1.4 billion population in India and probably 7 billion population to the world. That's how we can make the impact, right? So if you have to think about implementing a large scale project, for example, a project like Aadhaar, a national ID project which India runs, if you have to take it to the masses, you have to think of, if a decision has been taken to issue Aadhaar or not issue Aadhaar, or for that matter, any such large scale project in healthcare domain, or for that matter, any governance level domain, how do we ensure that people can understand the decision, and what are the measurements to explain those decisions, right? And that's where our unified citizen interface program, or the pilot that we are proposing, comes into the picture. We are essentially highlighting that when we are talking about people coming from different backgrounds, the program, or the whole auditable mechanism, needs to be multicultural, multilingual. If you're talking about India, 22 official languages and more than 1,000 unofficial languages, right? So the government AI ecosystem has to cater to the needs of this diversity, right? Similarly, when we talk about interacting with an AI system, then how you're going to interact if people are not able to type in English, right? So probably, can we do this in a voice control system? right? So and finally, like if you have taken a decision, if you have like released a 1,000 page, 100 page act, how can you summarize and explain this to normal people that this is what the act means? Right? The act is essentially a legal language. How to convert this into a summarization format, and how this can be explained to people, and this can actually cut across citizens, judiciary, policymaker equally. Right. So if someone goes to court of law, then even the judiciary needs to understand what the law is or how the government has taken a particular decision, and therefore the measurement across this kind of governance is very important. And that's where we are talking about having an evaluation framework. When we are using AI, it should not hallucinate in a governance setting, right? Very important. And it has to be consistent. The risks according to different applications need to be classified between low, medium, and high risk settings. And there has to be, as Amran earlier mentioned, with respect to standards and meteorology, these things need to be well defined. And as a next step, we are proposing and planning to actually do some small pilots to explain, to create an entire pipeline, end-to-end pipeline that can be then later on documented and utilized. With that, thank you very much.
Thank you, Mayank. Our last in this series is Professor Tanmoy Chakraborty.
Okay, so everyone wants to design powerful models, right? When it comes to how powerful the model is, how do we evaluate? We evaluate based on the accuracy. We create our own benchmark and show that, look, on our benchmark, our model performs 90% and your model performs 89%. So our model is powerful, right? And people keep coming up with more and more benchmarks and showing that, look, their models are better than our models. So the fundamental problem that we are trying to address here is how to think of evaluation beyond benchmark based setup, right? There are multiple problems in benchmark based evaluation. For example, if you think of two tasks, let's say there are two tasks in a same group, and both the tasks require some sort of knowledge extraction. Let's say typical, let's consider two very well known benchmark data sets like eFeval and MMLU. These are very standard data sets people use, and you see that, even within the same type of task, there are two different models which perform in two different ways, right? So which model to choose for a specific task? The second factor is, of course, data contamination. We know that, when these models get trained, they basically curate data from internet, and those curated data would be a part of their training, and that would basically leak your benchmark data. The third part is very important. If you look at let's say a same model family, let's say llama, right? So if you look at, let's say, llama 8 billion and llama 3 billion, right, the same family, both of these models perform very similarly on eFeval benchmark dataset, whereas they perform quite differently in MMLU. They belong to the same family. Now, if you look at same model size, let's say llama 3 billion and quen 3 billion, they are of same size, but one model performs better on one dataset and the model performs better on another dataset. So how do we choose which model is needed for your task? This is the fundamental question that you are asking, and we, the group of researchers here, we are trying to hypothesize that along with the accuracy based measures which are needed based on the benchmark, we also need to report something called the latent performance profiling of models, right? And latent performance profiling, we call it LPP. LPP is going to be a suite of metrics which would characterize the internal property of a model, right? Now here I am showing two examples of LPP. One is simply look at the entropy of the last layer of words, and the other one is participation ratio, which looks at how compact your layers are. I mean, these are just some of the example metrics, but you can also think of your own ways to measure LPP. And it turned out that these measures are related to the internal properties of the task. Let's say you are interested in some healthcare task which requires the entropy measure of a model, right? Now if you know that this model is superior in terms of entropy, you will choose that model, model 1, not model 2, right? So task profiling is important, and then model profiling is important. And we hypothesize that, I mean, this is our prescription. We are suggesting that when a model is released, in the model card, the LPP matrix also should be released, so that people will understand which model should be chosen for which task. Thank you.
Thank you. Over to Chet.
Thank you very much. Please give them a big hand. We now invite Professor Devdeep Mukhopadhyay and Professor Mainak Mandal to talk very briefly on a very, very important topic, the confluence of security and AI. So, on stage, short.
So, so we will be, like talking about a topic which is like last but not the least. So it is, like measuring AI, but with the context of security and safety. So we know that, like when AI systems have been deployed, there are multiple stakeholders which are involved. And some of them are affected by, like security issues, while some of them are affected by safety issues. So the question is, right, how do you really measure them? So if you look at the landscape of various attacks, which kind of thwarts the AI systems, there are concerns about integrity in the sense that, like whatever you are feeding as an input could be malicious, there could be potential trojans. There are fear about, like that your IP could be stolen, which are called as, the model could be kind of reverse engineered, the IP could be, like stolen. And at the same time, there are also like like there are concerned about privacy attacks where your coveted data can also be like be compromised. So NIST, while NIST kind of provides several attack scenarios, what remains as a concern is how do you really understand. So here is for example, like a slide which shows you that kind of shows you how fragile our AI systems are. As you can see here that there is a picture of pig, but with like with little bit of noise, it is kind of diagnosed as an airliner. So the good thing is that if you look at and like observe the AI systems which are deployed on the various platforms, you will probably get signals, and these signals are absolutely important to kind of like kind of differentiate the proper inferences from malicious inferences. At the same time, it is also equally important to kind of like equip your team with a red team versus blue team configuration, which means that like there should be kind of like measurements and performance of various attack simulations, and kind of like also considerations of the defense strategies to really kind of assess the AI systems that are deployed in various strategic sectors. So with this, I would like to kind of like invite Moinak to talk a little bit about the safety aspects.
Thank you, Devdeep. So, hi. So I'll just go quickly over and try to systematize as brief as possible as a state of the art for AI safety. So if you look into AI safety, which essentially means that AI system should behave as intended, which is as subjective as it can get, you can actually think, at least today, what problems we know in three broad categories. First one is intrinsic risk, second one is interaction risk, and third one is societal risk. What is intrinsic risk? That is something that comes from within the AI because they don't have some knowledge gap, they don't know something, they hallucinate, confabulate, and all these other problems. The second is external or interaction risk, which essentially means that problems that come up when the AI interact with the users just believing the AI and jumping off the cliff. That will be your interaction risk. And the third one is societal risk. When at societal scale, we have misinformation generated by AI or some problem or some automated usage of these machines to do some harm to society. And the reason, a core reason for all of this problem is measurement centric, because when developers create this AI, they just don't know how it will be used/abused in the future. To that end, what happens today is to solve the safety problem. In general, people measure or people try to actually defend them by a measurement based, rule based defense, which can be broadly categorized as a guardrail based defense, meaning that the AI should not really behave in a particular way. You actually put some rules what they should not output. And that is actually great because it will stop toxic vocabulary, it will stop PII or the private information leakage. It is pretty easy to implement. Just you can think of it as a modified version of if-else statement. However, it will also block benign
prompts. It will also does not really acknowledge the knowledge gap of the LLMs, and it can be easily jailbroken. That has been shown again and again every year, 200 papers. So the issue is that these guardrails are blacklist oriented, and the safety to make AI really safe, we need to be more adaptive, and this adaptation should be measurement based. So this is the thing that people are working on, including some of our recent work which looks into improving safety. So for addressing intrinsic risk, we tend to measure the knowledge gap of AI. We have built some system about that, looking into the last layer, looking into the prompt, looking into the actual training data. For addressing the interaction risk, we had work on measuring the appropriate norms of how AI should be used. What are people telling? What are the problems with it? Using a data-centric large-scale view. And finally, for addressing the societal risk, we develop judge models to do better in terms of safety of AI systems. But these judge models are generally done by the measurement result of norms and knowledge gaps. With that, we would just want to resonate that the measurement is of paramount importance for AI security and safety, because measurement will enable us to know that what is wrong in terms of what is insecure or what is unsafe, and it will also pave the path forward to mitigate it. Thank you.
We will take questions at the end.
Do you have? Sure. We'll get back.
Please give them a big hand. And we now move to the last part of our session, which is the panel discussion. May I request Professor Lipika De, moderator of the session, and the panelists. This is an international panel along with Dr. Kavita Bhatia, who is the national COO of India AI Mission. May I request Professor Wolfgang Nagel, may I request Professor Carsten Maple and Professor Siddharth Khastagir to kindly come on stage.
Good evening, everybody. So now we move on to understand how to measure the effectiveness of generative AI as it gets deeply embedded into the decision making processes of organizations. We try and focus on the best practices in AI measurement happening globally, and also try to understand what are the focus areas that India should focus on and lead. So, a brief introduction of our panelists, Professor Siddharth Khastagir. He currently serves as the head of Safe Autonomy at University of Warwick, WMG. He's a member of various international standardization and regulatory committees, including ISO, SAE, and the United Nations uh, Economic Commission for Europe on safety of self-driving vehicles. Professor Carsten Maple from the Alan Turing Institute, UK, is with Cyber Systems Engineering at the university's Cybersecurity Center. He's Director of Research over there and has worked with organizations in key sectors such as manufacturing, healthcare, financial services. Professor Maple is a fellow of the British Computer Society and vice chair of the Council of Professors and Heads of Computing UK. Then we have Professor Wolfgang Nagel from TUD, Dresden University of Technology. He's the director of Center for Information Services and High Performance Computing. Since 2014, he's leading the National Big Data Competence Center, SCADS, funded by German Federal Ministry of Education and Research. Finally, we have Madam Kavita Bhatia. She is scientist from Ministry of Electronics and Information Technology. She is the COO of India AI. She has led transformative initiatives like the National Data Governance Policy and the National AI Portal. She is the driving force at MeitY, impacting several national service delivery projects like Aadhaar authentication, Aadhaar data vault, e-sign, and single sign-on, etc., without which we cannot imagine our lives today. Welcome, our panelists. So, without further ado, let me straight away go to the questions. Professor Khastagir, my first question is for you. Unlike traditional software, AI measurability is not only about accuracy. Can deployable AI driven autonomous systems be designed to provide guarantees for robustness as well as regulatory compliance?
Thank you so much for the question. An absolute honor to be here. Thank you for the invitation. I think we need to separate out the two aspects of the question. One is the regulatory compliance, and the other one is the guarantees aspect. So, in the space of emergent technologies like AI, where even the regulators are trying to understand what should they be regulating, should it be a guideline, should it be a full blown regulation? So, if you take the approach in globally, you've got an approach in the UK and US, which is more on the guideline side, and then you've got an approach in Europe, which is more of a very stringent EU regulation. So I think let's separate out the regulation for a minute, because I think the regulators need to understand what they need to do. Thinking of it from a more scientific manner, I think when we talk about measurement and guarantees, we need to first identify what are we measuring before we go into the metrics itself. It's first we need to understand what are we measuring. So some of the work that we've done in WMG, and we work in a space which is a proper embodiment of physical AI, self-driving cars. And the biggest thing that we came out was in order to tackle this issue, you need to bound the problem. You cannot be working with an unbounded problem. And the way we bound the problem was try to make an argument for the training and the testing data sets as a representation of the real world. And we've come up with different ISO standards in this space. So we can talk about that a bit later but I'll stop there. In the main message is to bound the problem when it comes to representation of the training and testing data sets.
Great. So let's move on to post deployment. Professor Nagel, what do you think should be a way to evaluate AI systems after deployment?
Well, actually, we have not looked into energy. I think energy is an important point. We are measuring like it's not positional. Yeah. Okay. So energy measurement, I think, is important because at the end, somebody has to pay the power going into the systems. And the question you have put at the panel is a difficult one. On a worldwide level, I would say nobody can answer it correctly. We are doing projects in that area, so nice options to find out and identify how we can do that, but there's nobody who has an idea. We have 70 years of AI development, and the neural networks and the fast machines, the HPC machines, have enabled us to make very good success. And now, since we can talk to ChatGPT, everybody believes now everything is solved. It is not. And it will take years before we can guarantee that there are things coming. And I'm pretty sure that we need an opportunity to make sure that we can evaluate even on time that the models are not changing over time, like we have to do it with software in general. So that's to the answer.
Thank you for that very important point to remember, energy. Very important point. So moving on to Professor Maple, you work extensively in the areas of healthcare and finance, which are heavily regulated areas also. And given this uncertainty of the creative generative AI answers, what are some of the mandatory measurables that you think are needed for again deploying AI systems? And I would again like to also add, what roles will regulators play in this?
So thank you very much, and thank you for the organisers for giving me the opportunity to speak about some of the many projects that I have. We're fortunate in the UK. You mentioned that it's heavily regulated areas, and that actually creates an engagement strategy. And for me, one of the most important things is as we've moved forward. So, as Wolfgang said, AI's changed. I've been on a panel early this morning and a round table, and neural networks been around for a long time. Yeah, they died a death for a while, and then we got better at compute and algorithms, and we could do much deeper. But the thing is, as AI changes, we need to think about where it's being deployed. And in those two areas that you mentioned, we have to move forward and think about the system, not the model. Because you saw some graphs before from different models. Well, in some context, that might be fine because it's not really important. But unless we can really understand how a model, these sort of black box generative models, very complex. Unless we can understand how they're behaving, then it becomes very difficult to correct the behaviors. In the UK, the regulator I work most closely with, so I do a lot of work in healthcare, but in the UK, the Financial Conduct Authority has really been very proactive in its area. And one of the important developments that they created for quite some time ago now was the development of digital sandbox. And those sandboxes allow organizations to test their systems within a controlled environment. They've also engaged with the whole community from academics, from industry, to create a synthetic data expert group. Because at the end of the day, if you want to test, and I think, Siddhartha, you just said some great points about how we test. If we want to test, you need data to test. And that data must be the right data to properly test the data. I think one of the most important things is about conversations. It should be the community coming together because a regulator should be there to protect individuals and society. But at the end of the day, if it can do that by talking with industry, by talking to experts in academia, that will get the greater result.
Digital sandboxes, very good point. So I come to Madam Bhatia. What does measurable AI look like in India's setting, given the vast demographic and linguistic diversity that we have here? Which are the most important measurable metrics for us?
Thank you for inviting me. Yeah. Thank you for inviting me. This is a very important question. From the India perspective, I personally think it should be the inclusivity, language, and robustness should be one of the most important aspect when we talk about metrics of evaluation. In fact, India being such a large and diverse country, to me language is one of the most important thing which should be uh, taken into account when we are doing model testing. The In fact, we have taken a note of this, and as a part of India AI mission, we have already started working on it. We understand that the as it was also mentioned by Professor Mayank, that 22 official languages, and every few kilometers there's a different dialect. So which means that we need to make sure that the models should have the cultural and Indian context as well as the data on which it should be tested. Then only it will bring the concept and clarity of what India needs. So we have already started working on it, and in this regard, we have already selected, or we are working very closely with 12 organizations. Four of the models have been launched in this summit itself. You can in fact have a look at the models being showcased at the mighty stall. The second aspect, which I also think, is that the data, which is also very important. So we have taken a note of it, and we have already announced AI Kosh, which has 10,000 plus data sets, which are Indian data sets. It brings into all the cultural and diversity aspects. And also, we are making sure that the data has all those principles which was talked about, should not be biased, should be very uh, diverse. That all aspects have been done. Plus, with the mission which we have already called Bhashini, we are very closely working with organizations like police so that we can make solutions which are understandable to them in their language. And last, I think the model testing should be to evaluate the solutions on the low performing response based the model than the high. So I think language is one of the most uh, important aspect which I think should be a point of focus.
Very much. A minute each now for some quick responses. So coming back to Professor Nagel, you say that these are new. We really don't know a lot of it. So we would really like to know which important aspects of AI systems do you think we still do not know how to measure well, and what should be the international community prioritization to close the gaps?
Well, we are addressing, like you, the important fields. So if you work on healthcare, for example, it is clear that the answer has to be correct. And therefore, typically in Germany, it's not allowed that the system alone can direct the diagnose. It has to be always a medical person sitting in front of it and checking with his experience if this is correct or not. I think this is at the moment the most effective way that we control the answers. This is not scaling because you don't have so many people if you have many requests. But if you have people which ask for diagnosis, I think we have that stuff available and we'll do that.
Thank you. Professor Kastagir, I would like to ask you the same question. What is it that we still do not know how to measure well?
So I think bringing the two thoughts together, the data aspect and also not knowing. I think what we've been able to do in the UK is come up with a concept what we call as an Oasis concept, which actually creates an ontological model of the world for your particular use case, and that allows you to actually make an argument for completeness and representativeness of your data, because you can always say that the data should not be biased. Nobody would say no to that, but how do you at an engineering level prove that is the space that the researchers and the community needs to work on. So not just saying don't have biased data, tell us how do we actually at an engineering level create a bias free data. And to that approach, I think an ontological approach to actually classify the world is something that has succeeded, at least in the high safety critical industries like the one that I work in, self-driving cars, where we've been able to drive international standards on this ontological approach where people agree on how you classify or describe the world. A similar thing will need to be done for other domains like languages and others aspect. One last thing I would like to say, when it comes to standardization, we've been very fortunate in some of the areas, especially in self-driving cars and automotive. The research community has played a big role in driving the standards. I don't see that happening in other domains, because I think the researchers are the stakeholders who have the maximum high innovative in knowledge in this space, and they need to come on to those standardization platforms.
Thank you. Professor Metal, so now my question, do you agree with him? Can there be really common global benchmarks and metrics for AI, or do they need to be tailored to each country's data, laws, and culture? What's your?
Right, thank you. Thank you very much. And it's interesting because in the last 24 hours, we've launched some work from the ML Commons initiative. Some of you have heard of that. And that was really about creating a defensible and robust and rigorous and repeatable methodology for creating benchmarks. So I think there can be some models that are global. I think we saw it in some of the earlier talks about how you've got high level and lower level. So I think the principles based should be consistent so that we can have an understanding so it can be compared. But in terms of different sectors and in terms of different countries, that has to be tailored. And if you look at that ML Commons paper that's out in the last 24 hours, you'll see that we talk about culturally aware and culturally nuanced. So the example given in that paper is if you were to give a clock to somebody from the Far East, from China, for example, that is not a good gift to give. So if you ask a large language model about that, in the UK context, that's probably fine, but it means that there's a funeral pending. So not a good idea. So I think, yes, the answer is we can create global standards, but they need global benchmarks, but they need to be tailored for specific cases.
Thank you, Madam Hatia. Last word from you. Do you think there can be global standards and or they need to be tailored to each country's?
I think that the global cooperation on the foundation AI principles is essential, but it has to be tailored for every country because there is a lot of diversity. As I said, that there is a lot of diversity, and to have inclusivity, so we need to have a tailored benchmarks for every country. And in fact, just to highlight again that as a part of India AI mission, we have already announced an institute which is working with 13 educational institute on various aspects of evaluating the models to come up with the frameworks and all the aspects which are important for metrics. We are very closely working. So we thought that we will follow the global principles, but we will have the Indian context and Indian diversity and have the solution frameworks, tools which will be developed on the Indian requirements. So I want it to be that way, and that's why
Thank
we are
you.
working
That's very succinct. We can take possibly one or two questions. Yes, please go ahead.
You mentioned about bounding, right? And would you like to provide some examples?
Yes. Just on the mic. Sure. You mentioned about bounding is important, right? Could you give some examples which are closer to production use cases?
Yeah, sure. Thank you. So I'll take an example of physical AI, self-driving cars, autonomous vehicles, or automotive example. So one of the things that we've been able to do is create an ontology or a taxonomy of the world itself. So we then you divide the world into everything that is static, everything that is dynamic, and everything that changes in the weather. So we call it scenery, dynamic elements, and environmental conditions. And then you can create a whole tree around that. Then you use that tree to actually create your training set, your testing set, and then compare that to real world distribution of those aspects. So what we have been able to do is convert this tree into an ISO standard. So ISO 34503 is an ISO standard that the entire automotive industry is using and adhering to actually bound the real world conditions.
One more burning question. Anyone? Okay, go ahead.
Hi. So my name is Saksham, and this question is for the whole panel. I How can researchers, basically you mentioned that researchers are the main stakeholders, but researchers are not only situated in India, they're all over India. Even me as an Indian, I work in Germany. How can researchers outside also contribute to the research that is going on in India, being in another city or something else?
In fact, we want the researchers who are working outside to contribute in the foundation model, which I said that it should the Indian foundation model. And in this aspect, we are actually closely working with many of the researchers who are outside India, but Indians. We are working. In fact, couple of foundation models which we have approved as a part, or we are working closely as a part of AI mission, are Indian researchers outside, but were helping us in developing a foundation model. We had announced a call for proposal. Currently, that proposal we have stopped because we have received so many responses. We are not able to evaluate them. But shortly, we will again evaluate. And another thing which I said that AI Safety Institute, if Indian researchers also wants to contribute in the safety of AI, we have already opened one call for proposal, ethical frameworks and all. If you are wanting to contribute in that, you can submit your response to that proposal, and we will look into it, and the committee will decide, and accordingly, if as per our lines, it will be selected.
Thank you very much. Thank you, panelists. Thank you, wonderful audience, for being there till the end of the day.
So, first of all, I would like to thank all the speakers and the panelists. I would like to remind everybody that this, 1 hour session or 55-minute session is just the starting point of a series of events that we are planning on this topic. This already we had an Indo-German meet which came up with certain ideas, and then today, other than our group ideas and adding security and safety, this panel put up some very, very interesting thoughts, and we are going to take this up in a much larger framework. So any thoughts, ideas, anything that you have, I think please write to any one of us, and we will be very happy to include that and take that onto this. I request all of you to give everybody a big hand. I thank the organizers, especially Karthik, our spot, for doing this. And my institute has personally requested me to thank all the speakers on this behalf. So a small token. With this, we come to the end of our session. Thanks a lot.